Now we're going to look at our greatest integer function, is what these are. That's what this kind of funky looking bracket looks like. This is greatest integer. And what it really is it's a step function for every single number. The way we're going to find this is we're going to find out by rounding down. And I know these look weird. The program wasn't letting me put the right brackets on there. So we're going to go ahead and round down is what these are. So we're going to have a value of 2 here. Rounding down on 2.8, we get another 2. Rounding down on 3.5, we get 3. Rounding down on 0.1, we get 0. Sorry, my cat's meowing at me. Then we're going to have negative 3. Rounding down, we get negative 4. Rounding down negative 0.4, we get negative 1. Rounding down negative 0.9, we get negative 1. Rounding down negative 5.3, we get negative 6. So what this is this is my x value, and this is my y value. So we can kind of see what's going on here if we kind of start plotting these points up. And what it is going to look like is it's going to look like a little bitty step function. It's going to go from one block to the next with an open circle. And I'm going to have to zoom in on this. I'm trying not to zoom in too much because I know it's going to make the videos a little hard to watch. But everything between 0 and 1 will round down to be 0. Everything between 1 and up to very nearly 2 will round down to be 1. Everything between 2 and 3 will round down to be 3. So it's a step function at each integer. And it's going to look like this. And it's just going to take us a little while to draw them all. This might be handy to grab one of those graphs that only goes up to 6 on each side, because it's going to be less of these to draw. Because this goes down into the negatives too. I just started at 0 because it's easier to talk about when we are rounding from 0.5 as our x value down into our y value of 0. So it's rounding down. It's a step function about rounding down. That's what this greatest integer function. It's the greatest integer below. It's kind of like Price is Right rules. The nearest without going over. Oops. Got to keep it a function so we can't have anything that's directly underneath. That's the other reason we have a closed circle and an open circle on every vertical line, is it's got to stay a function. Otherwise, it's not a greatest integer function. So it's still got to pass that vertical line test. So that's what a greatest integer function looks like. When we're getting ready to do some transformations with the greatest integer function, we're going to do those same transformations, but it's going to feel like less of a table. So if we take a greatest integer function and we just multiply it by 3, it's just stretching it. It's doing a vertical stretch. So we're still going to have from 0 to 1 still rounds down to be 0. But if my x is between 1 and 2, 1 times 3, it's going to go up 1, 2, 3. And everything between 1 and 3 is going to round down to be 3. Everything between 2 and 3 is going to round down to be 6. Everything between 3 and 4 is going to round down to be 9, like this. So it's stretching it out. It still does a vertical shift or a vertical stretch. It's just on these little bitty steps. So it actually makes them easier to draw because there's significantly fewer segments when it has this vertical stretch. So we do the same thing with these greatest integer functions that we've done before. It's just going to be less of a table and more thinking through our transformations, and what that really means is going to happen in my picture. Is it going to make my bars farther apart? Is it going to make them wider? Is it just going to move everything up or down? How is it going to change my thing? So you're going to have to think through your transformations. This is probably the hardest one to do.